Color is an essential element in the design because each element needs color to be recognized. Color affects the human psyche and activates various emotions in its depth. In the current research, the effect of blue on IQ scores of neurodevelopmental conditions was evaluated, where intelligence is defined as the sum of mental abilities and IQ score reflects performance in intelligence tests. A field study was conducted for participants with low and medium IQs. This research assesses the problem of how to help people with neurodevelopmental conditions using blue. The aim was to determine the possibility of improving their performance. Next, please. Abstract. This paper aims to demonstrate the effect of blue on children with neurodevelopmental conditions, in particular, in order to improve their specifications. We have shown from previous studies the positive effect of blue color on similar participants. So we tried to confirm this result in this paper. The study included 40 participants with different neurodevelopmental conditions. We exposed them to blue color intelligence tests were administered for each of them. The study showed that exposure to blue led to an increase in the average degree of participants' IQs. The increase doubled with increasing exposure time. Next, please. Experience. Firstly, we made the color scale, figure 1 color scale, 9 colors, black, white, and the 7 rainbow colors, natural colors and its connection to human, Ibrahim El-Arabi and Dr. Reham Mohsen, AIC 2013, Newcastle. Next, please. Next, please. Secondly, we made a paper study of the effect of colors change on children with mental problems, Ibrahim El-Arabi and Dr. Reda Ali. Figure 4, relative effect of colors on children. As we see, indigo has scored 6, then green has scored 5.75. The less score was for yellow, 2 degrees. Next, please. Then we made an important study, the effect of space color on human. Case study, the effect of blue color on people with intellectual disabilities, Ibrahim El-Arabi and Dr. Usama Abdu. We exposed 33 participants to blue, while we left another group of 40 participants without exposure to it. The average IQs of the group that was not exposed to blue was minus 0.2, and that for the group exposed was 2. The difference between the increase of the two groups was 2.2 degrees. Next, please. Figure 2, the increase in IQ scores for each of the two groups. First group with blue, second group with orange. Next, please. In this study, 40 different participants were dealt with. Their ages ranged during a period of 2 years, 3 months, 21 days, and 30 years, 3 months, 21 days, with an average age of 5 years, 9 months, and 10 days. They were exposed to blue through curtains. We did intelligence tests on Stanford scale at the beginning of the experiment on them by specialized psychologists to obtain the overall IQ scores. Then we repeated tests. After 6 months, we got the following results. Next. Figure 3, picture of participants while they were in the Skills Development Center. We can see blue curtains. Next. Table 1, pre-test and post-test scores, classifications, and diagnosis of participants. Average of age was 5.78 years. Average of pre-test degree was 70.88 Average for post-test degree was 73.45. Average of the difference was 2.58 degrees. According to Table 1, pretest IQ scores ranged between 40 and 105, with an average of 70.88. The post-test scores ranged between 43 and 105, with an average of 73.45. The difference between them ranged between -6 and 11, with an average of 2.58 degrees. It is a good overall rate that shows the positive effect of the blue color in improving the IQ performance of the sample, as the participants who were not exposed to blue color scored -0.2 according to a previous study. Next, please. Figure 4, the difference between pretest and post-test IQ degrees. We can see that for at least degrees, there is a highest increase, and for highest degrees, there is maybe no increase. Next, please. Relationship of the clinical status to the increase in IQ scores. Table 2, average of the increase in IQ scores for each clinical status. As we see, the highest scores were for mental retardation, autism features, and hearing impairment and cochlear implants, where the least score were for hyperactivity and simple mental syndrome. Next, please. Figure 5, average IQ scores for each clinical status. We can see that the highest score for autism features and the least score for simple mental syndrome. Next, please. The number of participants in each status ranged between 1 and 8, and the average increase for each of them ranged between -6.5 and 7.5 degrees. Negative scores were for simple mental syndrome and hyperactivity. The rest of them had positive average increases. Chief among them are autism features, mental retardation, hearing impairment and cochlear implants, simple autism, and moderate autism. Next, please. Relationship of age to the increase in IQ scores. Figure 6 shows that the increase in IQ scores was mostly greater with youngers at the left and less with older at the right, which means that youngers are more responsive and benefit. Next, please. Relationship between pre-test and post-test results for IQ. Figure 7, relationship between pre-test and post-test results for IQ. Next, please. Relationship of increased exposure to blue color to IQ scores. At the left, figure 8 degrees for whom were exposed for 25 hours per week. At the right, figure 9 degrees for whom were exposed for 3 hours per week. We can see the difference clearly. Next, please. It is shown from previous figures that the increase in IQ scores for the group that was exposed to the blue color for 3 hours per week ranged between -6 and 7 degrees, with an average of 1.65 degrees. The number of negative degrees were 6 cases, while the number of cases in which the increase reached 0 were 3, and the number of cases with positive increases were 14. It is also shown that the increase in IQ scores for the group that was exposed to blue for 25 hours per week ranged between 0 and 11, with an average of 3.82. The number of cases in which the increase was 0 were only 2, while the number of cases with positive increases were 15. There were no negative differences. The effect of increasing the duration of exposure to blue on increasing IQ scores is very clear. Next, please. Sensible impact. 2 of the participants obtained an increase in IQ by 11 degrees, and it was found that these 2 cases showed tangible progress. One of them showed progress in social response, while the other showed progress in verbal skill. This tangible progress confirms that the increase in IQ scores is not just numbers, but it affects children significantly. Next, please. Conclusion. The study was conducted on a group of children with neurodevelopmental conditions who had IQs ranging between 40 and 100 degrees. They was exposed to blue by using blue curtains for an hour a day at a rate of 3 days a week to 23 cases, and for 5 hours a day at a rate of 5 days a week for 17 cases. IQ scores were measured for all cases at the start of the experiment. Then 6 months later, the number of participants whose IQs increased were 29 cases by 72.5%. The number that their IQs did not change were 5 by 12.5%. Finally, the number whose IQs decreased were 6 by 15%. The average increase in IQs for all participants was 2.58 degrees, where the average increase for whom exposed for 3 hours a week was 1.65, while the average increase in cases exposed for 25 hours a week was 3.82, equal 2.32 of those were exposed for 3 hours a week. This result confirms that the increase in the period of exposure to blue is directly proportional to the increase of IQ scores. Given the interval between pre-test and post-test, 6 months, it is expected that the child can improve from the level of IQ 40 to the level of IQ 70 within an approximately period of less than 4 years. Next, please. Recommendations. 1. Continuing studies in the same direction to help these children improving their performance. 2. Paying attention to the colors of architectural spaces because of their effect on users. 3. In the individual cases, a color test can be done for each case before starting the application. 4. Paying attention for helping youngsters whom seem to be most responsive. 5. Conducting studies on each clinical case if possible. Thank you. Thank you, sir.
Unfortunately,